Tutorial I'm going to show you how to construct diagnostic plots for simple linear regression models using SPSS. To facilitate this, I'm going to follow example 13.2 in DeVore's book, Intro to Probability and Statistics for Engineering and the Sciences. So hopefully you have that in front of you so you can follow along. Open on my screen right now is an SPSS data file including the X and Y values that DeVore presents in example 13.1, which the data carry through to example 13.2 in the text. So we have our X values and our Y values, our explanatory and response variables, and what we ultimately want to do is we want to construct a plot of the data, so Y against X. We want to construct two standardized residual plots, one where the standardized residuals are plotted against our predicted values Y hat, the other where our standardized residuals are plotted against our explanatory variables X. We want to compare our predictions and our actual response values, our Y hat and our Y, and then we want to construct a normal quantile or probability plot so that we can compare the standardized residuals to the hypothesized normal distribution. And in order to do this, we need to obtain our predictions from our simple linear regression model as well as calculate residuals from that regression model. So in order to do this in SPSS, we go to Analyze, we go to Regression, and we're fitting linear regression. And we've done this before in one of the videos, so we know that our dependent variables are Y, our independent variables are X value. And what we want to do now is we actually want to save information from the fitted model. So we click the Save option here. And to get just predicted values in the original scale of the problem, we select Unstandardized Predicted Values. For our residuals, in this case, the book is asking us to get standardized residuals, so they've been centered and rescaled. But we could also look at unstandardized residuals, and you can check either of those options in order to obtain those. So clicking Continue and then OK. SPSS will fit our simple linear regression model, and in a previous tutorial I showed you what information SPSS gives you about that regression model, so let's just focus on what's actually been saved at this point. So we have three new columns in our data set. The first column are the predictions. The second column contains the raw or unstandardized residuals. And then the third new column, this ZRE_1, as you can see, if you hover over that column, are the standardized residual values. So now what we need to do is construct different scatter plots in order to match our goals. So if you recall how to make scatter plots, we can go to Graphs, Legacy Dialogues, and then go to Scatter. And we're constructing simple scatter plots. And let's say the first thing we want to do is just plot our X and Y values and show that line of best fit. So we'll put our Y on the Y-axis, our X on the X-axis. We can press OK. SPSS will then give us a scatter plot. But we want to edit this scatter plot in order to obtain or show that linear fit. So if we double click on that plot, you're going to open up an editor window. Now before we do this, I prefer filled glyphs for scatter plots. So if you just click on one of the points and then go up here to fill color, click that, we're there. I just think that looks a little cleaner. But now we want to add that line of best fit, so if we go up here to Elements and Fit Line at Total, we're going to get a display, and we just needed to choose linear here in order to fit that simple linear regression model and then have that line displayed on the plot, which it does by default. So then we can just click Close, and we have our line of best fit on the scatter plot. Now it puts a label of that fit on the plot by default, and it can be kind of tricky to move this around, so sometimes it's in an inconvenient spot, but if you can, just try to move that, which as you can see is not always easy. Okay, and often it just pops it down to that lower corner. So if we do this and X out, you can see that we now have one plot showing the line that we fit against our actual data values. And then we could look at, well, are there any really obvious deviations from this linear fit or any unusual aspects of this fit just from what we see here. You can also see that we have the r-squared value in the top right of this plot. Moving on, we might want to more directly compare the linear fit to our actual observed y values. So in order to do this, we need another scatter plot. So let's go back to our data sheet here. Go back through the graph dialog to legacy dialogs and scatter plots. And then what we're going to do is we can just reset all these options here. And what we want to do is we want to take our unstandardized prediction as y and then use the x-axis as our y values here. And what this does is it makes a scatter plot comparing the predicted values and our actual observations. So if we double click, we can edit this. I'm just going to fill the glyphs right now. And then if we wanted to add any sort of line, we could do that. One option would be to go here to add a reference line from equation. And then we could just do y equals 1 times x plus 0. So that's a 45-degree line. And the reason we might want that 45-degree line on this plot is that if the predictions and the observations are perfectly aligned, so if our model describes all the variation that's out there, then all the points should lie on this diagonal. So it's a nice gauge of how we're predicting our response. So we have 2 of the 5 plots now. So if we return to our data sheet, now let's turn to what I call residual plots. And these are just special scatter plots. And the first residual plot that we'll make is of the standardized residuals against our predicted value. So again, we have to reset our plotting dialog here. And for residual plots, we're always going to want to put our residuals on the y-axis. And then in the x-axis here, we're going to look at our, where is that? Unstandardized predictions. And then we're okay. But we want to make this plot a little easier to read, because remember, our residuals are always going to be centered around 0, and then patterns emerging from this are what we're really interested in. So if we double click this, the first thing we might want to do, it's a scatter plot, so I would like to fill the glyphs in. But if you can look and see this unequal y-axis here, I don't really care for that. I would rather have the bounds in the negative and positive on this y-axis be equal or symmetric. So if we just go up here and click on this bold y, it allows us to change the increments and the range of these axes. So you can see we drop down to negative 2.5 on the y-axis, so let's just have it go up to 2.5. We can have that apply and close. So now I think our bounds are okay on each axis, and I'd like to add a reference line at 0. So we can go here to add a reference line to the y-axis, and then I'm going to put it at a position of 0, and then apply that. Now this will add a black line by default. If you're a fan of a different color, you can go to this line and maybe make that red or blue or something else. But now we have our first standardized residual plot here. And we can do a similar thing to get the plot of our standardized residuals against our explanatory variable x. So again, we go to Graphs, Legacy Dialogs, Scatter Plot. We're doing a simple scatter plot. And instead of our predicted values, we'll just slot in our x values. And then we edit our plot in a similar manner. So I'm going to change the bounds on our y-axis. I'm going to fill the glyphs. And I'm going to add a horizontal line at 0. And let's make that a red line. So now we have all of the residual plots, the 2 residual scatter plots, or regular scatter plots that we have from the textbook, and now we just have to look at this special scatter plot, which is a normal probability plot or a normal quantile plot. Both of these types of plots compare the values of a distribution to a special distribution called the normal distribution, which we'll learn more about later. But what happens is, if our observed values are consistent with the normal distribution, then we know this special scatter plot will align on this 45-degree line. So, doing this, we have to go through a different dialog now, and we can go to Analyze, Descriptive Statistics, and I would like to go down here to QQ plots. It's not quite what your book does, but it gives you a very nice plot. So we can select our standardized residuals. It's comparing it to the normal distribution here. We're not going to change any of these other options. We can click OK, and you can see that it gives us what it calls a normal QQ plot of the standardized residual. And as always, I'm going to double click this plot, edit it, and just fill in the glyphs there, and let's change the line to red to make it a little more distinct. And now what we have are, we're comparing the observed values of the standardized residuals to the expected values of normal deviates, so basically random numbers from this distribution. This looks a little bit different from what your textbook is doing, because your textbook puts the observed values on the y-axis and the expected values on the x-axis. So SPSS is just going to flip this, but it gives us the same information. If our points align closely with this 45-degree line, then we have relative agreement to the normal distribution, so we think everything is okay. In this case, we don't have much deviation from this 45-degree line. Remember, minor wiggles aren't a big deal, and we don't see anything too systematic, so it looks like everything's okay. This is how you can construct the most common residual plots and scatter plots for the simple linear regression model.